So it's completely unpowered right now. If we were to plug it in, power would come in through here, regardless of whether the relay was turned on or off. This transformer will pick up signal from it. So that is one function that I tried to make sure we would have, is that even if the relay wasn't allowing power to be supplied to the appliance, the entire box will still be powered. And I was able to achieve that. So that's kind of nice. This transformer right here will supply 12 volts of DC power to the board, which is used by the Arduino Nano over here and the relay. The relay is a 12-volt relay, so that was perfect. The Nano, however, is not 12 volts. I think it requires about 5 volts. However, it does have a built-in 20-volt voltage regulator in it, which was kind of nice. So I was able to give it 12 volts with no hassle. Then the Arduino has a 5-volt out pin that it powers the Bluetooth module. The current sensor, which is kind of hidden under here. Let me see if I can get it. It's that black square down there that says A on it. And then this blue thing over here is our thermocouple. Yeah, those all get powered, send the signal back. We ended up not using these clamps that we 3D printed to hold the cord in place, but used what are called cord grip bushings. These are 3/4 inch cord grip bushings. So we had to Dremel out the holes a little bit to make them quite large, but now the cord is secure in place. Won't move around on both ends. That's kind of nice. And then we have our current sensor. Our current sensor is just a ring of magnets. It clamps on and only to the hot wire. And by using magnetic fields, it's able to accurately determine how much current is flowing through the wire at a certain time. So you'll see in our relay, we have 3 terminals here. We have this one is the common, and this one is normally closed. So if there's no signal going to the relay, the switch is normally closed, which means it will allow power to be flowing through. So I will quickly move on to the demonstration. I will plug the cord into the wall, and as soon as I plug it in, we'll see the Christmas tree light up, and we get some lights going. So we'll first look at the relay, as I feel like that is the most important part. We have 2 LEDs. The one LED that you see is on right now, and we have another LED on the other side. This LED shows that the relay has power. The other LED shows that a signal is being sent to it that makes it turn off or reverse its polarity. Anyways, you can see the Bluetooth. This is the Bluetooth sensor blinking, showing that it is sending signal to our app, which I will showcase right now. 1 second. All right, and here it is. Is it mirrored for you guys as well? Is current backwards? Professor?
Yes.
Okay, well, that's a shame, but I assure you, we did not make the app backwards. So
it looks normal.
Oh, it does? It looks normal? Okay, I guess it's just mirrored for me then.
Yeah.
So here we are. The first thing you do is tap the Bluetooth symbol, and then you'll tap the one that you're connected to already, HC05. Give it a second, and now we're in. In a short while, it'll start displaying values. These values will be small. So this is in milliamps. Just recognize that that is less than an amp. Most current sensors are not accurate at small values, such as under an amp, but the temperature is pretty accurate, sitting there at 19 degrees Celsius, that is. Not Fahrenheit. We're not dying over here. So now I will demonstrate the various sensors by using this hair dryer. Over here, we got a hair dryer. Whew. And I'll turn it on, and we'll see the current sensor change. And we can see it go up, spike up.
Yeah, well, good.
There we go, to about 4 amps.
Very good.
Spikes up to about 4 amps. Sorry for the noise. And now I'll demonstrate the automatic shutoffs. So Garrett mentioned the various criteria for the app to shut off, for the relay to shut off. One of them was 12 amps, and the other one was 35 degrees Celsius. Now, those are very, very low numbers. We did this for the demonstration purposes. Those numbers can be changed, probably something more around 20 amps and maybe above 60 degrees Celsius. but we
cool.
set them artificially low so that we could actually attain them during the demo and show that they work. So right now I'm going to do the 35 degrees Celsius. So I'm going to take this hairdryer, I'm going to point it at the thermocouple, turn it on to hot, put it on low. We'll see it go up. And there we go. Turns off automatically. And you can notice the other light on the relay has turned on. So now the way to reset the cord is there is a built-in reset button on the Arduino that resets the code. Press that. There it goes. So the relay flipped. The hairdryer stopped receiving power and turned off automatically. And that was kind of nice. The next I will do is I'll do the manual override. So we have it going. I'll point it away so that it's not blocking my sound. Hopefully you guys can still hear me. Press the manual override. Once I press it again, there we go. Relay turns on, hairdryer turns off. If I press it one more time, relay swifts.